Okay, so we are looking at problem 84 in Leetcode, largest rectangle in histogram. It's hard, and it's indeed a hard problem. It's difficult. Given an array of integers heights representing the histogram bar height, where the width of each bar is 1, so we have a bunch of histograms, the width of each one of them is 1, and we have the height written. Return the area of the largest rectangle in the histogram. So if we have here 1, 11, this is 11, and here 1, 10, then we have here 2 times 10, and this was the max. And now let's go to a manual example again. Okay, so let's put down a histogram. Let's say this is 1, and we have here 2 and 3 and 4, and then we drop down to 2 and 1, and then suddenly 3. Okay, 1, 2, 3, 4, drop to 2, 1, and 3. So if we just take a look at this, then we could be tempted to start with this and say the height of the first one, these are the indexes. You could be tempted to say the index, the first one is 1. So let's check how much can we get out of this one. We could get this, but maybe we should check. Okay, so this was n. We scanned n items, but maybe we should also check this one. This one is also n. And this one is also n. So we get 2 of n squared. And not only this, we even need to check this one here. So, well, this could work. Obviously, checking all the options, brute force solution is maybe be good for the start, but obviously not the solution. So when we try to look at this, it's kind of, how the hell can we do this? There's just no option. We have to check everything. But looking at it more closely, we see that we can apply a pattern, because first they say largest. So we see we have max, and maybe we can apply this so far pattern that we described before. So far, because whenever we see largest or max or get a single value out of multiple integers, then maybe we could apply the so far pattern, which means we go gradually and we gradually calculate the maximum so far. What is maximum so far? What is maximum so far? What is the maximum so far? And in this way, we try to avoid the n squared or n third complexity, time complexity. But it's not enough, because in order to calculate the max so far for 1, we must go over all the items and check how many 1 do we have. So it's not good enough. So another pattern that we could apply here is that, you see, we have here some gradually increasing sequence, and then it breaks. So the pattern here is a slope change. Slope change. Why is this important, this slope change? Because when we have arrays of numbers with slope change, then when we could reduce the problem to some part where we had an increasing slope, and then do something else when it decreases. Okay, so let's see if this would help us. So let's try this changing slope pattern. So let's say that I do not go and intend to do any calculation as long as it's increasing. So here I do nothing. I just remember the index. Here nothing, here nothing, here nothing, because it's increasing. Once it's decreasing, then I say, okay, so I had the 4, which is max so far 4, and then I had 3, which is bigger than 2. 3 here is bigger than 2. So I had 3 plus 3, which is 6, which is the max so far. And then there is 2. So let's continue. Okay, and then it breaks again, and we'll do the thing again. So basically what we are suggesting is this. We are suggesting to have some kind of memory, the so far max memory, and to have another section with a data structure. Okay, and once we have this, we can say, as long as it's increasing, let's reduce the problem to the changing slope. Change slope. As long as it's increasing, I'm doing nothing. All I will do is write down the numbers that I have. So 0, for index 0, I have the value 1. For index 1, I have the value 2. For index 2, I have the value 3. For index 3, I have the value 4. Doing nothing. I do not yet calculate the max, but now it breaks. It breaks from an increasing slope to a decreasing slope. Only here I will do something. This is also a pattern of looking backward. Look, once something breaks, I look to the backward. Why do we do these things? Because this would allow us to calculate things faster. Just patterns. Programming interview patterns. So this broke. So because this broke and I'm intending to insert here the 2, I will not insert it. I will check all the numbers that are bigger than 2 before 2. As long as it was increasing, I know it was increasing. And I will write the max so far. So max so far here was 4. And then max so far here was 3 times 2. 6. So I have a max so far of 6. I'm going then to remove from the data structure these 2 and insert these 2 into the data structure. But now that I'm inserting these 2 to the data structure, I can actually insert it until here. It's basically representing now this section. So I insert it with index 2. So now inserting, don't have enough space. Let's continue this here. Okay, so I'm going to insert it here, the data structure. Continue here. And now I will insert the 2. So I'm inserting 2 with index 2. Okay, is it increasing? No. So again, I need to apply the look backward and calculate, because I now have 1, which I want to insert. So I have here 1 and I want to insert it, but I will not insert it. And so I'm increasing and I go to 2, 2, and then it's dropping again to the 2, 1. So it's dropping here to the 2, 1. So I need again to back off and check what do I plan to do with this. So here I'm backing off, and what I'm going to write here is that I have a 1 that I want to insert, but before I insert that 1, I'm calculating backwards. So here I had 2, 2 until the index 1. So I had 2 times 3, which is 6. Okay. And until the index 1. Okay. So I'm removing the 2. I'm removing the 2 because it does not change the 6 here. So I'm getting rid of all of this. Actually, this is 2 times 8. So, okay. So we'll take these, which are 2 times 4, which is 8. So this is actually increasing it. So it's increasing it. So it's now 8. And I'm now inserting the 1. But where would I insert this 1? I actually insert it from the index where it's going to start contributing for me. From here, from index 1. So I'm inserting 1 and 1. Okay, and now it's increasing. So everything is okay. I put 3 on the index 6, and now it's the end. Okay, in the end, finished the first stages. Now in the end, I'm going to check. I have here 3. 3 does not increase this, but I can take into account all the ones from the beginning until this, because I know it was increasing. So I have here 1 times 7, but it's less than 8. So I have the 8. And now that we have this scheme of going from the left to the right, when it's increasing, only update this table and do not yet update the max so far. When it's decreasing, update the max so far and remove all the items that are larger than the current one. When finished with everything, with the loop of this, then go over the numbers that are left and just remove them by calculating what's the max so far. So it's hard, it's complex. This is why it's complex, and it's not easy to explain this. It's hard, but these are the steps, at least in this solution. This is why this problem is hard. Okay, so now let's go ahead and actually code this. So to actually code this, and in this case in Java, we're going to get the same steps. Let's first initialize our memory with a pattern. So first initialize the max so far. Okay, and now let's have, if you remember, then at the top we had a list or a stack that we kept updating with all the indexes that we had. So let's initialize this. This is a list of int, one int. Let's see immediately. Wait, list. So this is going to be an int, because if you remember, then we had for each item two values. The index, let's say the index was 2, and the value that was 6. So this is a small trick in Java. Just hold an array of 2 items for each item so that we can hold each 2 items without creating a new class. And now let's add the first item. Add a new int. And the first item is at index 0. So we have here 0, and the height of it is height at index 0. This is the first item. And now let's loop over all the items and start do all the indexing matching. So for each item, this is another trick. We go from index 0 until I is less than height.length, but also -1, so that we can safely iterate 2 items. When we need to safely iterate 2 items, we can go over item at index 0 and then until -1, so we can safely iterate 2 items so we don't get bumped by index out of bound. Okay, so we iterate the list, and now we are going to check if it's increasing. As long as it's increasing, we don't update the max. All we do is update the list. So as long as it's increasing, the height of the current index is less than the height. This is height. So as long as the height is less than the height of the next one, and because we are looping until index -1, we won't get into a bump on the index out of bound. As long as it's increasing, then what we do is just update the list. A.add new int, and here we take utilization of the fact that it's an array of int, array list of int, and this is the index of the increasing item, and this is its value, the new value, as long as it's increasing. Okay, if it's not increasing, we need to update the max so far. So let's count the number of the item that we removed, because it's a hard problem. Nothing we can do about it, because we said that then the index of the new item would be the index backward. So let's count the number of removed items that we had, and let's point to the last index that we are currently in at. Okay, here. And now let's find the max item. Let's find the max item. And because we're moving backward, we need to remove items that we already dealt with. So in order to find the max item, the max so far, and to remove items and to update the list, it's a hard problem. We need to go from the current index of from the current latest item that we have on the array, because this is the latest item that we're about to pop. And as long as we didn't reach the beginning of the new index list that we have, yeah, I plus 1. And as long as it's decreasing, a.get. So we are moving on the list that we have created. And we move backwards, and what do? We update the max so far. So max so far, this is the first time we actually update the max so far, except for the initialization. Is when we move backwards, we said the backward pattern and the so far pattern. Math dot max, the max so far pattern, and the current item. Yes. Current item that we have times the difference in the indexes, okay, till our current item times, oh my god, so this is times until the current item. So yes, until the current item, which is from the index that we are currently at on the overall encapsulating list, until the current item that we have. Okay, so now let's update the last index that we are in. Okay, we're just repeating what we did. And then we are removing the item that we took into account in the max so far. This is the latest item on our list, or if you treat it as a stack. And we need to count how many items did we remove so that we can add this new item into the pointer which is previous, because then we'll calculate the bigger rectangle int and last index and heights, and this is the new item that we currently add. Okay, what a hard problem. Okay, so now we finished with the going forward, going backward. We finished with the outer loop, with this outer loop. So now we need to go over the reminder items in our internal list and calculate what's left. So int I is a.size -1, go over all the items, and as long as we have items in this intermediate list that we have, then update the max so far. We are going backward again. Amazing. Max so far, and we get the current item, and for the current item value we time it times the how much items we have left. Okay, because we have the index, we need to calculate it until the end of the list. And now that we've calculated it, we are going to go backward again and return at the end max so far. Okay, amazing. So we did basically what we said we were going to do exactly in the algorithm. Let's try this. Okay, let's just fix a few typos. So a new int, right. Right. So A is a list, and A is a list of integer array. Yes, and then A dot add new. This new is not appearing in the color. New int. Yes, we don't need this. Yes, new int, and we add this item. Okay. $9.15, just fix something. So if not if, but for. Okay, so for I is from the end of the list, as long as J, yes, as long as we didn't reach the beginning of the list, and yes. So again, for int I, go over all the items, and we're going over height. Height dot length. Num removed. Okay. Num. So this is going to be num removed. So num removed. Yes. Okay, this looks better now. Now let's submit it. Lot of indexes here. Yes, and we see it's okay. So this was the solution to this hard problem of calculating areas. Largest rectangle in histogram. We described here a few patterns, how we don't calculate for each item, how we find it. It's a hard problem, so we are going to calculate backward and use the max so far pattern.